Why is pi 3.14159, and so on? Pi is one of the most well-known mathematical constants, defined as a ratio of a circle's circumference to its diameter. This irrational number has fascinated mathematicians, scientists, and engineers for centuries, and its approximate value of 3.14159 has been calculated to trillions of digits with the aid of modern computing. But why does pi take on this specific value? The answer lies in the fundamental properties of circles and the nature of mathematical relationships. The definition of pi. Pi is a mathematical constant that appears in the formula for the circumference of a circle, c equals pi d, where c is the circumference and d is the diameter. Since this ratio remains constant for all circles, no matter their size, pi is a universal constant. If one measures the circumference and diameter of any perfect circle, the resulting quotient will always be approximately 3.14159. The history of pi and early approximations. The search for a precise value of pi dates back thousands of years. Ancient civilizations, including the Babylonians and Egyptians, recognized the importance of this ratio and attempted to approximate it. The Babylonians estimated pi to be around 3.125, while the Egyptians used the fraction 256 over 81, which is approximately 3.1605. One of the most significant advancements in the understanding of pi came from the Greek mathematician Archimedes around 250 BCE. Archimedes used polygons to estimate pi by inscribing and circumscribing them around a circle. He determined that pi was between 3.1408 and 3.1428, a remarkably accurate range. By the 14th century, Indian mathematician Madhva began using infinite series to approximate pi. Work later expanded in Europe during the 17th century, providing even more digits of pi without geometry. The mathematics behind finding pi. Pi can be found through many mathematical methods. Archimedes' polygon method was one of the earliest. A more modern method is the Monte Carlo method, which uses probability. By plotting random points inside a square that contains a quarter circle, one can estimate pi based on the ratio of points inside the circle to total points. Another method is using continued fractions, which represents pi as an infinite sequence of nested divisions. For example, pi is equal to 3 plus 1 divided by 7 plus 1 divided by 15 plus 1 divided by 1 plus 1 over 292, so on and so forth. Modern computers use advanced algorithms like the Gauss-Legrand algorithm and the Chudnovsky algorithm to calculate pi to trillions of digits with great precision. Why pi is not a simple fraction? For centuries, mathematicians tried to express pi as a simple ratio, but in 1768, Johann Lambert proved pi is irrational. Its decimal goes on forever without repeating. In 1882, Ferdinand von Lindemann proved it's transcendental, meaning pi isn't the solution of any algebraic equation with rational coefficients. It's also proved it's impossible to square the circle using only a compass and a straight edge. The universality of pi. Pi appears in many fields beyond geometry. In trigonometry, it defines relationships between angles and motion. Engineers use pi in building anything with curves, wheels, bridges, or gears. In physics, pi shows up in wave equations, orbital mechanics, and electromagnetism. It also appears in statistics, especially in the normal distribution. Culturally, pi has a symbolic meaning. It's celebrated on Pi Day, March 14th, and its infinite mysterious nature inspires mathematicians and artists alike. Modern applications and computation. With technology, pi is now computed to trillions of digits. While most fields, like NASA, only use 15 digits, Exploring more digits is a challenge for mathematicians. Pi is also used in medicine. For example, it's used in MRI scan reconstructions, cryptography, and computer science. Its relevance goes far beyond theory. It powers real technologies. Pi is 3.14159 because of the nature of circles. It's a constant found not by convention, but by geometry and reality itself. From ancient approximations to modern algorithms, humanity's fascination with pi reflects our deep desire to understand the universe. As one of the most essential and universal numbers, pi continues to inspire discovery, curiosity, and innovation.